This ample line, yeah, that is. Because the whole point is to capture your screen
Got
with
it.
high fidelity.
Makes sense. Okay, share. That's it. Cool. All right.
Perfect. Get that away. I've done this a lot, so
Yeah,
yeah. All right. Okay, I think we're ready. Are you mic'd up? Yes. You want to test it?
Hello.
Okay. Hi, everyone. Evening. We're gonna get started because we have a pretty tightly packed schedule and a lot of stuff to go over. I just came back from. My name is Sean from Strix. Again, so a lot of people who have no idea that I don't work for AWS, at least not yet. I run Late Space and the AI Engineer Conference. We just did the first AI Engineer Code Summit last weekend in New York, and it's a high profile coding agents conference, and I felt guilty doing that in New York and not anything here in SF. So I summoned some friends, including Charlie, to talk a little bit about the stuff in work we're doing and put out a proposal for some Unity audience to put stuff up. The rough order of speakers will be as listed in Luma. So I'll announce whoever's next, but I just wanted to give it over to Charlie, who's been doing super interesting work on orchestrating all the coding agents. So you want to take it away?
Cool. Yeah. Thank you. Thank you, Spix, for having me. And it's cool to be here. My name is Charlie, and I'm the co-founder of an app called Conductor, which lets you run a bunch of coding agents on your Mac all at the same time. Something I wanted to start with, just mostly out of curiosity, is I wanted to figure out who has the highest CC usage. I'm guessing people here have run NPX CC usage at some point, right? I'm curious if anyone is over $100 this month. Raise your hand. Okay. How about 500? Okay, so I got some hands. Okay, how about 1,000? Okay, got a few hands. How about 1,200? Okay, what are you at? 1,800. Okay, 1,800. Does anyone have a higher usage than that? Okay, you get a conductor hat as a reward for your cooking usage. Okay, that will find its way to you. So if you're the kind of person who, like this guy, you burns a lot of tokens and actually gets anxious if you're not using tokens all the time and wants to be an AI maximalist, Conductor is probably a good app for you to try out. So I thought it'd be fun to tell you a little bit about how we got here. Show you a quick demo of how Conductor actually works, and then I can tell you about where I think things are going. So my co-founder and I started our company last summer, and we discovered about halfway through the summer this CLI tool called Aider. Are people familiar with Aider? Okay, nice. Okay. So when we discovered Aider, we were like completely blown away. And I still think of Aider as like the godfather of everything that's happening, of like Claude Code and all the CLI tools that are coming out now. And I like Paul Gaultier, the creator, like deserves a ton of credit for this. But we found Aider and we were like completely blown away. And it felt clear to us that things were moving away from humans editing files with human brains and like human hands to AIs editing files and humans managing them and dictating what they should do. So we had the idea of creating a code editor that wraps around Aider. Okay, and we called it Melty, and it was an open source AI code editor. And very quickly, we realized that wrapping around Aider and having like relying on Aider and Sonnet 3.5 as like the engine for our app wasn't quite going to cut it. You needed to open the files and look at them a bit too much by hand. Like you couldn't really trust Sonnet 3.5 to do things end to end. we got a bunch of open source traction at the time. And in hindsight, it was kind of funny because we released this and we were like, okay, we're going to do an AI code editor and it's going to be open source. And little did we know that that would sort of become a meme. I don't know if you guys remember this and Pair AI. This is kind of just like a tangent, but like while Pair AI was like a I think a fork of Continue, which was itself a fork of VS Code, and it kind of became a meme to do this. And it's like we kind of like managed to like be behind the scenes on this, but this was actually our first press. Okay, there we are. On top of that, YC funded two other AI code editors. Okay, and we were, and I like this, as the mob was quick to point out. Anyway, so we couldn't really rely on Aider or Sonnet 3.5 to like be the engine for this app, and we made basically took on too much. Like one thing led to another, and you're forking VS Code. This was a very easy and dangerous thing to do in the summer of 2024. And we decided to take all the things we had learned messing around with coding agents and like the UX of coding agents and applying them to chat. So we released an app called Chorus, which you can still download. And I could give a whole talk on Chorus, but the main reason Chorus has been valuable for us is because first we learned how to make desktop apps. And second, we learned to develop really, really fast because we were using like every ounce of all the AI tools that were available to us. So I actually tweeted about this quite early on in Cloud Code's history. Like we became such power users that at one point I had like 5 clones of the Chorus repo, all with a different Cloud Code session. This is before I like knew what work trees are. I still kind of don't know what work trees are, even though like they're fundamental to our new app. But we now like they're totally abstracted away. But anyway, like we were complete Cloud Code power users. Um, and we decided we were going to try what we had done the summer before, but instead of building a desktop app around Aider and Sonnet 3.5, we were going to build it around Claude Code and Sonnet 4. And so I feel like whenever like founders talk about like an app that they released and it was really got really popular really fast, they always say like we released this thing and we were like blown away by the response. But honestly, I just like kind of knew that this app Conductor was going to be a hit. And part of why I knew was because like we just wanted it so badly ourselves, and we had been thinking about it for so long that like we knew it was gonna like we knew at least some people were gonna care about it, which I'm not sure I could say about the other things we worked on. And so the high level overview is Claude Code or Conductor is a wrapper around Claude Code and now Codex, and around Git. So you never have to think about creating a work tree or an isolated environment for your Claude codes. You don't have to think about checking out branches and creating PRs. Conductor just like abstracts all of that away from you. So let me just open up the app and I can show you a bit about how it works. Okay, there is light mode. It doesn't look as cool, but we have it, yeah, of course, yeah. Okay, so maybe I'll just quickly show you a little bit about how Conductor works. Feel free to ask questions as I walk through it. And then I can tell you about where it's going. So this is what Conductor looks like. On the left, we have a list of our work trees. In the middle, we have our chat. And on the right, we have a mix of version control stuff and a terminal. So I'm actually going to go into this workspace. It's called Honolulu. And this is in the me repository, which is actually the repo for my personal website. And I'm going to start it off. I'm just going to start by saying I'm using Opus 4.5. And I'm going to say, can you change? Yeah, let's just try this. Can you change the links on my website from Melty to Conductor? Because I realize I actually haven't done this yet. Like if you go to charlieholtz.com, you'll still see that I'm working on Melty. So now Conductor is going to start working. you can see that already it's changed the branch name. So our branch is now called Melty to Conductor Links. We have see some tool calls. It's reading some files. It's now editing some files. And when it's done, we're going to, you can't actually hear it, but there's a little choo-choo sound effect. And we're going to see what files it's changed. Okay, so you're probably used to seeing Cloud Code, but like already we have like kind of, I would say, a pretty nice looking UI around Cloud Code. Then on the right, I can see all the changes that Claude has made. So let's just try clicking on one. Okay, so we can see it's changed this melty link to conductor.build. And then we can go into this other file and we can see, okay, it's also changed this melty link to conductor.build. Okay, so that's kind of cool. I would say where conductor starts getting powerful is the things built on top of Git. So let's say I want to actually not change this URL. I can just click comment as if I'm in GitHub, and I could say actually leave this one as it was before. I can add a comment and then press enter. And then Claude is going to take a look at my comments and then like make adjustments based on that. Okay, so it's now you can see the changes are just in this index.html. I can now press this button, create PR, or I can press Command Shift P. And now Claude is going to make a PR for me. And while Claude is working, something that like I kind of think of all these coding tools as having like three essential elements. There's like you put in there's a place to put in the context, which in this case is like the composer. There's a place to like iterate with the AI, which in this case is like this middle chat. And then there's a place to test your changes. And like all three of these need to work well, preferably in one app for it to be useful. So our solution to testing changes is this big play button. So I can click run workspace, and now the dev server for my app is going to run. I can just press this open button, and it's opening localhost, whatever this is, 4406, and you can see that the link has been updated. So I think that's pretty cool. Finally, I can see that now this big PR button has changed from create PR to merge. So Conductor is aware of my Git status. I know like this might not sound like a lot, but like it took a lot of work to get all the possible all the possible states of Git to reflect well in this sidebar. And so now I can, instead of like going to my terminal and saying like GHPR create and all that stuff, the branch is created for me, the PR is created for me. I can just hit this merge button. All right, it's merged. I can open it in GitHub to prove it to you. Yeah, I think that deserves a shot. Okay, so now that the PR is merged, I can click archive and the whole work tree will be deleted and won't take up any more memory on my machine. So I think that's like a pretty trivial example because like that's just like updating one thing on my personal website. Like you know that Cloud Code cannot like already do that. I think like the real power of Conductor comes when you start juggling multiple workspaces all at the same time. And so over here, you can see this is my Conductor repo. So this is like the actual repo that we use to develop Conductor in. And I don't know how well you can see this, so I'll just like make it super big. But like here is a list of like actual things that I was working on. I can click into each one of them, like get a whole history of like the iterations I went back and forth with Claude on. I can make a new tab, kick off a codex agent to also take a pass at these things and compare them. Um, uh, I mentioned that it was like really complicated to get like Git states all reflected well in the app. If your validations check, Conductor is aware of that, and it adds this big fix errors button. So I can just like click that, and Conductor is going to start working on like the failing CI actions that it pulls in. I think another thing that's like kind of an essential part of my workflow is like I mentioned, like it's really key to like bring in context from other apps. We're power users of Linear. And so there's a direct linear integration where I can just press Command I and look through I can see like the linear status based on like this little icon. I could say add themes. It pulls in the context from linear, including like the comments. I can just hit enter, and now Conductor is working on that linear issue. It even changes the branch name to match the linear issue. So linear like reflects the status uh, of this chat. I can spin up a workspace running inside this particular chat. And so now like very quickly you find yourself in a spot where like you have a bunch of stuff happening all at once. I would say like there's really like you quickly hit a point where there's like a cognitive limit for like how much like a human can handle here. I'd recommend working on like maybe like 2 to 5 things at the same time. Um, but once the work is done and like the checks pass, you can easily like go through, review everything you want to review, add comments if you're like, this function looks weird. You could even click a big review button and it's going to spin up a new tab with a request to review all the changes in that particular branch. And there's like so much to explore here. Like I don't want to just like go feature by feature. I just want to kind of like throw a bunch of stuff at you and say like this thing is really powerful. And like if you're a AI maximalist or someone who's like trying to burn a ton of tokens, you should give this a try. Curious, any questions about this workflow so far? I know I just threw a lot of info at you. Yes.
First, how does conducting differentiate in the sense that it shares multi level vision association, but in the sense that it works with these separately and different tabs, are there any opportunities for them to work in unison, like say you have a use case where you have Claude and Sonnet together in conjunction with Codex?
Yeah. Okay. So it's a two-part question. One is Cursor is in a similar space. There's actually a ton of competition now, all with a very similar like UI. Like, how are you going to compete in this space? And the second part of the question is, can we bring in context from other tabs or like share context between tabs? I'll answer the second part first because it's way easier. We actually added this feature today where you can make a new tab, and when you make a new tab, there's this tooltip. I'll make this really big so you can see it, which says add context. And in one click, I can click, like, let's say this one, and it's going to create a summary of this, whichever tab this is, the implement GitHub Gate rate limit warning tab. And then that's going to be added as context. So I think there's a lot more to do here, but like we're just starting to add more sharing context between workspaces and tabs. To answer the first part is like, how are you going to compete in this space? I remember like very early on in the Cursor days, I was Aman, who's one of the co-founders, was demoing me. At the time, it was called Copilot++, which then, for many good reasons, got renamed to Tab. And I thought it was cool. And I was just kind of like chatting with him. I was I remember it very clearly saying like, okay, so Cursor really is just like a sidebar in VS Code where you can like talk to ChatGPT. Like, isn't like Microsoft gonna add that like next month? What's your what are you gonna do? Like, what's your moat here? And he like thought for a moment. He was like, yeah, I think we're just gonna like move faster than them. And I love that answer. It's like so simple and like kind of inspiring and just like, and he was totally right. And so that's really my motto with Conductor is like we're just going to move absurdly fast and be obsessed with this one particular problem, which is a UI for managing your coding agents. Any other questions? Yep.
Are you able to sort of set models for certain tasks and shortcuts?
Yes. So you can create a new workspace and like let's say I choose Haiku 4.5 here. I can go to the settings tab, and for my reviews, I can choose what I want my review model to be. So I changed it to Opus 4.5 yesterday, but a lot of people like using Codex Max, which is really impressive with like high thinking level. And then when you're doing that, and now if I click the review button, you're going to see that GPT 5.1 Codex Max is going to review.
And that's what I'm playing right now.
Yeah, cool. Yeah, and another thing that I really like about the review feature is that like compared to like tools that add reviews to your GitHub PRs, like even though I like a lot of them, like having the review in the same place as where you iterate on the code is really helpful because like the review is going to happen in Conductor. I can then just send another message and it's like all in one place. Um, Something I also didn't mention that I think is like a really powerful escape hatch here is that we don't restrict you, we don't keep you inside Conductor. So for example, like let's say you're looking at this file and you actually like just want to like use cursor tab or like you're like a huge Z fan or whatever. You can just press Command O or click this button, and then uh, it's going to open that file in whatever code editor you choose. So then I can make some changes here and blah, 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 and then go back and there's a refresh, but it's going like I can just edit the files like directly in whatever like code editor I want. So often I'll like start things off in Conductor and like use it as like my work tree manager, make some changes in cursor, and then like create the PR and merge it in Conductor. Yes.
The agent harness used for the non-cloud.
Uh, so the agent harness we use is just like native codecs or native cloud code. Some people are really big Gemini fans. And so for that, I'd recommend doing this, making the terminal really big and having Gemini on the side here. Yes. Okay, the question is, do we plan on supporting real coding models? Wait, what was it?
Amazon Q developer.
Oh, Amazon Q developer. Okay. Wow, that's such a good question. Uh, if it's good, we'll support it. Yeah, yeah. And I'm not saying it's not good, but if it is good, we'll support it for sure. Yeah, yeah.
Do you have their content?
Yes, yeah, yeah.
It's just in Q&A now?
No, I have a couple more slides. Yeah, yeah.
Go into that.
Yeah. Okay. All right. So, okay, where was I? Okay, so I just showed you how Conductor works. I should probably show you that my website has updated. So that's kind of cool. Okay. Oh, there goes my. Okay, 1 second. I pressed Apple Q. Okay. Where's our next slide? Okay.
I would say is
I
they
need sound on this, by the way. I don't think so. Okay, I'm gonna bring up this quote as well. Okay, so I've been getting a lot of questions about this. Yesterday, Cloud Code announced their desktop app integration, and Sawyer tweeted they just chucked Conductor into the Cloud desktop app. When the Cursor agent was announced, one of the Raycast founders posted this: the Cursor just Sherlock Conductor.build. I sort of already answered this. I find it kind of funny when like people like founders are asked like where they think the space is moving, and they always have like an answer that like is really perfectly positioned for their app to take off. So I want to just play this quote, or actually I'll just read it out loud because I don't think the sound is going to work well from Dario, where he says, as we move towards agents, there's going to be a world where the AI model can do something end to end. The human's main job is kind of just to check. But interestingly, checking often means getting really into the details of what happened. Okay, so there's some kind of impedance mismatch here. Some product or interface is a solution to that. You want something as slick as possible that just goes off and does something, and you don't have to pay attention most of the time. But when something's wrong, you actually need to get quite involved. And so this is really the mission of Conductor, is to be that app, to be that interface. I don't know exactly what the details are going to look like and like where the models are going to take us, but I do know that it's going to feel something like this. Okay, you're going to be the conductor, and like a great conductor, sometimes you're going to be like, okay, like horn section, like tuba, like I need you to play like a little bit louder, and then you like can zoom out and be like, okay, strings, you play in this key, and then like you get everyone to play like in unison. So like a great conductor, you need to like zoom in on the little details, but then zoom out and keep everyone in rhythm and like keep the orchestra together. And so that is the mission of conductor. If you're at all interested in joining us, we're growing really fast and looking for our fifth person. So come and talk to me, or you can just. It also works if you just try out the app at conductor.build. Thank you for having me, and happy to answer any more questions.
Okay, so he's gonna take questions, but also I need Matt Palmer if you're here. Matt? Hey, okay, so I'll set him up while you take questions, yeah?
Great. Yes.
There's a Zoom just for
Can you say that one more time? Oh, yes. Yeah, so the question was our worksheet manage the dependencies. So we have something called
got it, yeah?
script, which is
Share the
a
screen.
script that runs every time a worksheet is created. So the one that's used, for example, basically runs copy.env and run pmpmi, and then every time you make a new work tree, it's like ready to run.
More question, probably.
All right, no more. What? Yeah. Yes.
What's the sandboxing for?
Oh yes, the sandboxing story. The sandboxing story is we run everything in YOLO mode on your machine. So this is very much for the AI machines. We're planning on moving things to running in containers and probably running in containers on the cloud. But so far, YOLO mode is the way we're doing it.
Sure. Should be, yeah.
All right, so much.
Yay! Oh my god.
We're just opening with this.
You didn't have to do that.
That's the point of the talk.
Very kind of.
Do I have a mic?
Yes. We need to mic you up.
No, I can just use the handheld mic. It's all good.
Hello everyone from Reddit.
Awesome. Thanks for the introduction. Great to see everybody here today, and also thank you, Charlie, for the amazing talk. I guess this should be on the screen.
Is it not? Is it?
It says it's sharing.
Okay, maybe you need to. No, so this is not. That's on the Zoom screen.
Oh,
That's
shoot.
You're plugging in that screen. It's okay. Don't worry about it.
We're doing it live.
While he's going, Juan from Minimax is here. Okay, hi, I'm gonna come over to you guys. Okay, this is anyone from Amazon side able to help on the Okay, gotcha.
Yeah, I'm just not seeing the display mirroring here.
Can you try? Do you have a native?
Yeah.
You can.
HDMI.
Sweet.
Try a native there. Maybe.
Okay.
Thank you so much, Anja.
Amazing.
Woo!
1 sec.
Almost.
Okay, so choose content. No. I think we're gonna start mirroring entire screen. Okay, then I need to present to the Zoom. Amazing. Okay, so we're presenting to the Zoom. We're sharing the screen. Yeah, I think we got it. We got a presentation. Amazing. Thanks for bearing with me all. Swix reached out to me like yesterday and was like, hey, do you want to give a talk? And I was like, sure. We're giving a talk. Anyway, it's going to center around this image, which I really enjoyed, and I think the entire team at Replit enjoyed it. Has anybody in this room seen this before? Hands in the air. Okay, so like nobody. You don't follow Swix on Twitter. That's what I'm hearing here. So this is the semi-async valley of death. I love this image. And you can think about it on the x-axis, there's agent autonomy. On the y-axis, we have like productivity, right? And this is for coding agents specifically. So on one end, we have really autonomous background agents. You don't do anything. On the other end, we have synchronous agents. You're working in a flow state. You're trying to be really like mind meld with the computer, right? And so the point of this talk is that I'm going to make the argument that on the left here, on the left, we just have developer experience. And on the right, we just have delegation. Now in the middle, we have death, which is not good. There are also going to be jokes in this talk, so y'all can lighten up about some of this stuff, right? Thank you. It's nice when I can thank individual people for laughing at my jokes, so we're off to a good start. And the point I'm going to make in this talk is that actually these things are the same but different. So we have DevX, delegation, and death, avoiding the semi-async valley. And I have 10 minutes here. So we're gonna really get going on this. And I'm Matt, I lead developer relations at Replit. Don't worry, there'll be plenty of times for pictures and whatnot. And we're gonna open up with death. I know, I'm keeping it light. But death, if we're using coding agents, looks a lot like staring at outputs. It looks a lot like situations that are too fast to walk away from, so you're kind of like waiting for the outputs, but too slow to kind of like flow. And we want to avoid this. You know, I think Conductor is a really great example of how you can manage multiple agents and kind of be in a flow state maybe with one agent as you make smaller changes, and then kind of have this juggling act where you're coordinating multiple agents in the background, right? And so the flows we want are long async flows where we're hands off with background agents, or short, tightly integrated flows where we're really in a flow state. And this is where I'm going to talk more about developer experience and what that means. And you know, we're like 3 minutes in and I have Drake memes, Ricky Bobby, we're just going to keep rolling through it. This is going to be a fun talk. So this is a triangle. I don't like many triangles, but I like this triangle. That was also a joke, but again, we're keeping it light. If you got that one, that was pretty good. So this is the developer experience triangle, and developer experience is composed of 3 parts. It's feedback loops, flow state, and cognitive load. And if you like read anything about developer experiences, like kind of agreed upon in the industry. And I think it's important because I don't know that there are many people thinking about developer experience as it pertains to AI native workflows. Now, at Replit, which is where I work, we're building mostly for semi-technical builders, people that maybe have some experience to code, but want to turn their ideas into prototypes, turn their ideas into working apps, but we're also still seeing a lot of devs. Like, #1 user still signing up says they're a developer. What that means is open to interpretation, right? What that also means is that good DevX needs to apply to both. Or as we're building Replit, we need to build for both of these users in mind. And the truth is that what we call developer experience is not specific to coding, right? If you're like fixing a lamp or working on like a larger project, you still need to optimize for feedback loops, you need to optimize for cognitive load. I'm also sorry for like flashbanging everyone with a giant white screen in this room. So you need to optimize for these things by maybe assembling your tools first, or going through diagnostics or debugging, right? And these are like builder experience things. And so for developer experience or builder experience, we're optimizing for tight feedback loops and a low cognitive load. And the goal is to get into a flow state. If we're fixing a lamp, if we're working on a car, we need to be able to focus, right? That's the whole point of being a developer or being a builder. And so as I look at this kind of triangle, right? Feedback loops look like rapid iteration, right? We want to be able to iterate really fast. Maybe that looks like using a lightweight model like Haiku, or building a client-side application. We don't want to switch context because every time we have to go out of our code editor of choice and go into a tool to like spin up a database or manage our secrets, it takes us out of that flow state. And these two things contribute to our flow state. And so as I think about this is good. More Drake memes. As I think about this, right, if you think about context switching, really it just looks like infrastructure. And maybe those are things like if you're building and touch the cable. Yeah. We're back. I won't touch the cable again. And maybe that looks like things like adding a database, adding object storage, configuring secrets, or even deploying the apps that you're building. Maybe it looks like any number of other things. And so for rapid iteration, if cognitive load is about infrastructure, rapid iteration can be thought of as a harness, right? Maybe when we want like a harness that moves really quickly or allows us to edit files. Charlie talked a little bit about that. Or maybe it's more of a heavy harness, maybe like a multi-agent that allows us to test both using an LSP and a visual editor, and it has excellent context management. And so both of these things are tools that humans use to get into a flow state. But I kind of want to make a different argument here. So we talked about the semi-async valley of death, and I've been mostly focused on developer experience. Well, what does it mean to delegate? In an age of AI, delegation means handing tasks off to AI and expecting them to do them for us, right? But these are the same tasks that we do ourselves. And so it's not really about developer experience, but it's about agent experience. Cat jump scare. The presentation has it all, folks. So I'm trying to get people excited for the lightning talks. So it's really about agent experience. And so this is the point that I was trying to make on the opening slide, which is that it's really the same at both ends. We have to optimize for feedback loops and flow state, whether we're doing that for a human or whether we're doing it for an agent. And now I'm going to apply this specifically to Replit. How do we do that? The Replit agent uses high levels of autonomy at one end of the barbell. It has the ability to test the apps that it creates, both visually using Playwright and through the LSP and through looking at code. And it has really great context management. You can actually completely destroy a Replit agent instance and drop it into a brand new app, and it's going to be able to pick up where it left off. So a practice recommended by Anthropic. And so when you're building an agent, we've recently added these autonomy selectors. So you can plan for larger pieces of work, but then you can also toggle from low to max autonomy to be able to build things that are more hands-off, right? Now on the flip side, we've recently released fast mode, design mode, and more low autonomy settings to allow you to get into a flow state. Because what we saw was we talked a lot about product managers, a lot of designers, and they're saying, oh, hey, actually, in our meetings, we want to build prototypes like while I'm talking to somebody. Personally, I think you should probably pay attention when you're meeting with somebody, but we want to enable those folks too, right? So, we have our low autonomy modes as well. And so, that might look like design mode, building client-side applications using Gemini that are 1 to 2 minutes in build time, but that produce impressive results. And so, interestingly, we started from high autonomy, kind of hands-off background style stuff, and then worked our way back towards the other end of the barbell. And we found this was really important because people care about that developer experience and those feedback loops. Now, the thing that underpins all of these is infrastructure, and that's Replit, right? And so I'd be remiss if I didn't mention why this is important. Replit, no installation or configuration, it runs in the browser. We have built-in tools or services that allow you to build apps with AI and deploy them in seconds. And that includes things like adding custom URLs, adding login, and sharing them instantly. So in addition to having a mobile app, the whole idea is that Replit is just a platform by which we're building this AI tool on top of that can use the same tools a developer would to build something really cool. And so, we bundled this up in a nice package. I'll show you a demo that I built in a couple of minutes while I was sitting in the crowd and I got distracted. But avoiding the valley, my kind of take here is that good DevX is really just good agent experience. It's kind of a mouthful. And that autonomy is really constant both across the builder and across the agent. And so how do you implement this? Well, you can challenge your tools, whether you're using something like Replit or Conductor or any of these other tools. You can ask yourself, well, do I find myself doing the same things over and over again? Or is there a way to automate this? If I'm working in a repository, right, can I add in rules or documentation or CLI tools that agents know how to utilize such that I can stand up background agents in this repository and it can help me get work done in an asynchronous manner? That's something we did with our documentation. And thinking barbell, I think in all things is a good approach, which is really what I love about Swix's graphic. And in all things, avoid the middle, right? So there's one other thing that you can do, which is seek pain. And I think as developers, if you're frustrated about something, if you find it annoying or angry, or you get angry about it, or you're lazy, that's actually good, because you will have the pain to go out and change that thing. Now, coincidentally, seek pain is also a company value of Replit, and we are hiring. So QR code there. Swix told me to put in a hiring link, so that's my segue. Again, I'm Matt, replit.com/careers if you're interested. And then I'm going to hand it off in 1 second. I'll give people a chance to scan, just to show you, because I like to show rather than tell. I had a fortune cookie before I came in here. It says, an act of kindness will pave the way for new friendships. That's pretty great. So I built a fortune cookie app in Replit. And I did it using this approach. I said, hey, help me build a minimalist fortune cookie simulator with a nice imagery. Notice this is in Replit. It's running in the background, in the browser. I didn't install anything. It designed my app, and then I chatted back and forth to add fortune cookie generation with Gemini 3. So I could say, generate me a fortune cookie about multi-agents. And the nice thing about our AI integrations is you don't even need an API key. We just build it through to your Replit account. So you can integrate these things very rapidly. Together, diverse minds unlock extraordinary possibilities. And then I added a database so we can store these fortune cookies, and I deployed it live to Cook AI engineer at .replit.app. So end to end, that's what that process looks like. But again, I'm Matt with Replit. Thanks y'all for coming.
We're gonna have Tron next, who's gonna come over and set up, but otherwise Matt can take some questions. The other thing I'll plug for Matt, he's actually really good at developer videos. If you're making anything video-wise, he just published blog post, I guess, or
something to getting like really rapid token output that a lot of providers are enabling. And so as we talk about this feedback loop, right? If you could like stream thousands of tokens per second, that'd be pretty cool. Even if it's low quality, right? All right, this is the hook. I'm out of here.
nice job. I do want to emphasize, I actually like pulled together some of these like top speakers on very short notice. Only San Francisco could do this. There's such high quality builders and officers. One for Minimax is, first of all, thank you to Minimax for the wonderful food. You guys like it? Yeah. Yeah, anyway, thank you so much. Tuan. I think you have to put your headset on and then I can turn it on for you. There's a button that you have to press. Cool. Is it in? Okay, can you speak? Yes.
Hello. Hey, it's okay.
Okay. Yeah, I think we're very pleased to have Minimax is one of the leading open source models, and we're pleased to have the Eng. Go for it. Go introduce yourself.
Okay. I will start, but before my topic, I let's have a little break. Okay. I still appreciate some beautiful dance. Let's see.
Oh, this is Huyan.
The song.
Silk spins tight like a dancer's dream. Die. On the night.
It's
anyhow, it's okay.
Yeah. It's stay here. Just stay here. Go down. Yeah, go.
Hi, hello everyone. My name is Chuan. I'm from Minimax. Chuan is a Chinese name, so it's the same pronunciation like the president Trump. It's easy for you to remember Trump. Okay, so I come from Minimax. I think maybe any one of you have ever heard of Minimax. So it's so popular. Thank you so much. After the meeting, you can have more credit and ask to me. I will give you coupon or vouchers. Okay. Okay, so you have you ever seen my just the video about our dance? So it's a very beautiful dance for different style, ballet or tango or some traditional dance. So this is our new Minimax video model. So we call it here Minimax 2.3. Hilo 2.3 video model. So it can generate a very dynamic and real human-like dancing. So this is I think is the most advanced dancing mode or dynamic mode in the video generation field. So you can try it later. Besides of the video model, so we also have the speech 2.6 model. So it's a human-like TTS. You can see, okay, it's very you can do voice clone and do TTS synthesize for your text script. So I want to have one demo here, but check this usually.
Todos. 今日はみんな元気ですね. I have to tell you about something that is honestly straight up magical.
Yeah.
Like it's giving me music vibes, but for your coding and agent. Okay, so listen. Minimax M2. It is literally the strongest open weights model for Replit agent and conductor. それはね、open weights の新しい時代です. So, developers, don't leave me waiting in the rain. Go check out Minimax M2. Download the weights. Be enchanted.
Yeah, this is before the meeting, I do one demo. I cloned one superstar's voice and then ask her to generate one M2 slogan for us for this meeting. So we just use different languages, Hola and Genki desu ne from Japanese and Spanish and English to promote our M2 model. So today's topic is about our M2 model. So before, besides our video, besides our voice cloning TTS, then we have our own TTS, own new model M2 we published. So this is Minimax's model, multi-modality family, the video, the speech, the reasoning model, and also we have our music and the MCP and agent model. So this is the first, we excel in all modalities. And then we have all AI native apps. Maybe you use our Minimax Hilo, Minimax Audio, Minimax the agent or video agent or Talkie. Yeah, this is the second line is about our AI native apps. So Minimax was expertise in the multimodality and also the AI apps. So this is our Minimax briefing. So let's go to the topic, the Minimax M2 model. The M2 model is an open weighted model. We just published last month. So it's a very small model, only 10 billion activity parameters, and it's very light. So it means fast and cost efficient. Besides its size, it's specially designed for agentic and coding, especially in the workspace environment. So this is the M2 model's main advantage. So here is the performance. During the latest AA artificial analysis ranking, Minimax model here, we are in the number 5 in total all the models, and we are ranking number 1 in the open weighted models. So that's the latest rankings, and we specially designed for coding and agentic scenarios. So in the software engineering, SWE verified and SWE multi-bench, we also ranked in the open weighted number 1, just the follower behind the Anthropic and the ChatGPT. So this is our positions for the M2 performance. Right now, in the Hugging Face, in the first week, Minimax M2 model was downloaded and ranking number 1 in the first week of the Hugging Face download leaderboard. And in the Open Router, we can see in the first 3 weeks, we ranking the number 3 in the throughput usage during the model. So that means it's a very popular and wild adoption in the scenarios. So that's why is the M2 is so popular. So we have 4 main parts to improve the performance in the agentic and the coding. So I will introduce one by one. So here is the four topics. The first one is the coding and the developing experience. So during the training stage, we have scaled a lot of data for the data environment and expertise. For example, we use the multilingual codings. So we covered a lot of languages, all the languages, the JavaScript, TS, HTML, Python. And then we have a real GitLab repositories for 100,000 environments. We test in the racks and issue tests. And also this M2 model, we support very high concurrency. That means 5K sandbox per 10 seconds. That means 1 second we support 500 sandbox invoke. So during the training stage, we have defined our problem in the coding and agentic. For example, the problem definition, the model behaviors, evaluation, and reward. We use the reinforced learning to train the model, and then we build different environments to give the expert developer the friendly model, and then we get them feedback round by round to improve our reward models. So this is the ranking for different languages. We ranking number 1 in the C#, C, and Ruby, and in the Python we ranking number 2 for this model. So in different languages we have in the top 3 or top 4 positions. The second about our behavior for the training is the long horizon state tracking. We introduced the interleaved thinking and reinforced learning. So here is the sample of what is interleaved thinking. So if without this interleaved thinking, so when we do agent work, so the first time we got the job or the query, we have one thinking, and then we have different tool calling, tool response, and we give the final thinking and the final content output. So introduce the interleaved thinking. So when we do every round, the tool calling and tool response, we have one independent thinking for each round of the tool calling. So that will reduce the error rate or increase the robustness for the invoking. So that's why after our practice and our test evaluation, the interleaved thinking will highly improve the final output quality. So that's why it's very important for our innovations. So here is the sample when we do the AI stock competition. So Minimax M2, we are ranking the number 1. So if we are for example, the stock agency, so Minimax will earn the most money. Here is the trend. You can see we compared with different models. Minimax AI stock earns the most money. The third one is about the robust scaffold generalization. So that means we have because we developers have different environment, have different library. So it will cost when we output the final work, it will have a highly failure rate. But we have a lot of data for big data perturbations, so it will increase the robustness. So here is a sample for agent for generalization for tool scaling. So we adopt perturbations across all the models entire operational space. So you can see here during the tool information, prompt, user prompt, and tool response, we all have our tool. Will have our data and evolve perturbations. Sorry. It's so bad. I'm a little nervous.
It's okay.
It's okay. So the final 4, our model size. As I mentioned, our model is only 10 billion parameters, so it's very light and fast, and also cost efficient. So that's why we are so popular in this new agentic and coding scenario, and we are so popular in the developers. Okay, here is the four advantage, and for summary, I will give you one sample for one task. For example, we want to use the agent, the Minimax agent, which adopt M2 model to do one Tesla stock analysis. So we give him we'll give this agent one job. I'd like to through analysis with the Tesla stock. So So it will explore different environment and do the web search and do different back end, front end development, and then give the final SWOT analysis. So we can see the final result. So it will give us a final website to show the different aspect from our queries. So here is the here is the final output. Yeah, the company overview, the financial analysis, technical analysis, and so on. So you can try the M2 model in your agent or in Minimax, the Minimax purpose multi-purpose agent. So you can, and also you can also integrate in your cursor or cloud code. So this is why my cursor using M2 model can output one, for example, the orchestration conductor for multi-agent. Well, I'm still running right now. Yes. Okay. Here.
Okay, I think that's
Finish. This is my all topics.
thank you, John, for the presentation. Thank you.
Yeah. Thank you.
We're gonna take questions. I think Patrick, where's Patrick?
Okay.
He's gonna take over, but you can take one question.
Okay.
Never use Zoom here, right?
No.
Teams all the way.
Yeah. Exactly.
Can you put your
Yeah. For sure. Yeah.
Actually, you can roll translation. It is for many purposes right now in our user
Can you bring your slides?
put it to that.
Yeah. Okay. Thank you. Thank you very much. Yeah. No. You use this. Okay. Yeah. Okay.
Just double click. Double click. Yeah.
Oh. Sounds good. Yeah, thank you. All right, so thanks, Xuan. So today I'm going to talk about a similar topic that we got presented with Minimax. Models that are small, cheap, fast, and specialized. So the one I want to talk about today is called Farah 7B. When Swix announced that they were spots available for today, at Microsoft, I just realized we had a model coming out yesterday from Microsoft Research called Farah 7B. And it's a small model that is designed to do computer user agents. So really drive your computer. So that's what I'm going to talk about. I'm going to do a quick demo of that. So I'm Patrick Chanezon. I lead the DevRel team at Microsoft, and I've been at many different places before. I gave another talk earlier about AI agents with a Microsoft perspective, so you can find a bunch of things in there as well as in this blog post.
So this talk will be more just focused on FARA 7B. One paper I really love is the Ethan Mollick paper from a few years ago, talking about the fact that the frontier to what AI agent can do is jagged. And really in computer use, we see that a lot. And I think FARA 7B is going to help with that. So it's a model that shipped yesterday that is based on a Quen model. And the researchers at Microsoft have trained it with synthetic data to use computers in a small model that you can run on your laptop. So it's small enough to run on a laptop, and what you can see in there is that the performances that it has are like really comparable to some of the best and most expensive models. So it runs faster, you can run it locally, so you have privacy plus speed. And so this is something to try it out. So the tools available to it are Playwright. It can click X and Y, type, and then have browser-specific actions like search or visit a URL. The new thing that the researchers have created in there is that they train this model based on synthetic data generated from a multi-model agent framework that they have created. And so they created a bunch of tasks, then run them through the model. So the model, the agent described what these tasks should be, and these are tasks such as booking a plane ticket on a website, or booking a restaurant, or things like that. Then there's a multi-agent model that runs the solving of the task, which is really going through the task. And then there's and several agents are involved in there, including, you can include a human in there. And then there's a task verification where you run a model to evaluate all these tasks. And these 140,000 trajectories, including 1 million steps, constituted the training model that they used to train that Quen 2.5 model to drive a browser in an efficient way. So that's kind of what the new thing is in there. And you can find more details in the research paper there. There's another interesting angle that they added to this, which is they released a new benchmark, and it's on Hugging Face, so you can find the data in there to test with a more realistic set of tasks, computer user agents. And so if you want to learn more, you can find the paper at the first URL, the GitHub examples at the second one with some code, and I'm going to show it briefly. And then it's part of the the Microsoft Foundry catalog, and you can ask more questions in our Discord channel over there. So I'll just start presenting and just show you some code in there. Okay, so here we're in VS Code. So that's a Python script that uses this. I deployed the model to AI Foundry. So I'm just going to show you the deployment there. So FARA 7B is part of the AI Foundry catalog, but you can also find it on Hugging Face in there, and you can download the weights. The model is an MIT license model. You can see that Minimax is also on the Foundry catalog model, and here you can see I deployed it on AI Foundry. I've put the settings in my projects for how to use that in there in the file. And there I'm just going to run a simple agent that's going to take some text as an input for what I want the model to do. And then it's just going to run the agent loop, and there are a bunch of parameters that you can set in there. So the test I'm going to do is I'm going to ask it, I passed my config in there, and I'm going to ask it how many pages does Wikipedia has. And I'm going to run it in headful, so we're going to see what happens, but you can run it easily in headless. So here it's starting a browser, Firefox here is going to Bing, is going to search for the Wikipedia pages, and then it's going to analyze the page, and the model is really looking at the page like a human would do. It's not looking for the accessibility underlying tags. It's really looking at the page like a human would do. And so here it gives me the answer. Wikipedia has that number of pages. You can run like more complex example, and there's a GitHub repository to get started with it that you can find over there. All right, so that's it for R70. Thanks.
Thank you so much. I think we're gonna have Vivo up next, but if anyone has use cases for computer use agents, anyone, any questions, feel free to ask.
Yeah, is the traffic from the model blocked in any way by some new Cloudflare agent filtering techniques?
I don't, so the question, sorry. The question is the traffic from the agent blocked by the new Cloudflare or anything? I'm not sure. All right.
Oh, so only
I don't know. I haven't seen it.
okay. All right, lightning talks, 5 minutes, I was told.
As a curator, sorry, this one should have gone right after the conductor one. So just pretend this is right after conductor.
Okay, conductor was like
Okay. All right. You want to go to your slides?
Mm-hmm.
Yes, you're good. Oh, you're not
No.
connected. Is it showing?
So,
Yeah. Okay. Amazing.
okay.
Okay. Canva.
You have to get the last minute, sorry.
Okay, hold it close to your mouth.
Hi everyone. I'm Uma. Wow, this is a big room. How many of you are backend devs here? Could I just get like a show of hands, please? Okay, great. How many of you have actually written API code? Awesome. How many of those APIs have been more than 10K? More than 10,000 APIs? Okay. What's the highest you've written? What's an approximation? Over 10K? Yeah, great. So the thing is, for the next 60 seconds, we're all going to pretend that APIs suck. And we're going to just villainize the concept of API and from a first principle thinking, because this city loves talking about first principle thinking. So adding some buzzwords here. So essentially, what we want to be doing is we want to try to find a new way in which we can rethink the concept of APIs when we're building for AIs in general, right? So I'm just gonna go here. So this is what a very simple API looks like today. And this can go out of hand very quickly if you're working in a big organization with like tons of things to write internally and externally as well. And the thing is, we want to change this. We want to make it easier for developers to talk and communicate, be it with clients or servers or language models, without writing a bunch of this code. This is like literally 20 plus lines of code just for calling the weather API. So that's insane. So what we're doing with Incribo is we're building an open source framework which is task based, and it's designed to help you kind of replace writing APIs in the backend and kind of like communicate and connect with servers and language models as is. So this is what you can do with Incribo. So on the platform, you will be able to just like add all of your GitHub files and essentially create all of these function calls that you can just simply call in your backend. So this will help in reducing the maintenance and overload with regards to APIs in general, which can go bad very quickly. Some of the features of this tool is it's session based. You don't need to worry about authentication and sending headers and cause errors and all of those things. It auto validates before communicating with any of the servers that you're trying to connect with. It is disposable, so once the request has been successful, it immediately combusts or self-destructs. So you don't need to worry again about hacks and malware attacks and any of that. It is very task specific, so it does have certain restrictions, and like we're trying to build around that. And we're trying to make it AI function call specific as well with the V1, so that some of the basic things that you do when you're talking to AI and LLMs in general is already baked into the framework. And of course, it's TS native because we love TypeScript. And it also auto terminates. So you don't need to like specifically close anything, or you don't need to terminate the calls. It immediately and instantly and automatically ends the function. And if you are a dev and if you're interested to talk about this problem, you can come find me here. Any questions? They're from my hacker house.
So supportive.
Yeah.
We'll move you to the side to get to take questions. And then also,
we do have a special guest, Oreo. Okay, if you want to come see. Have Jared next talking about spreadsheets, which is my personal favorite.
I hope it will be so everyone's as well. Okay. Great. I hear and see nods all around. Fantastic. So hi, I'm Garrett. I should give you a little bit of background. I am a neuroscientist, or was a neuroscientist, previously switching over to AI engineering. My perspective is very different and counterintuitive to what's going on tonight. I am I don't try to understand what the data space they're in and make the process or the agent as efficient as possible. I've recently joined a startup that is focusing on spreadsheets. And I'm going to tell you why they are very fundamentally different than tabular data and why they're much more gnarly to pick apart. So let's get started. So this is the core problem. You've got this nice little table that you can see on your screen. You can see that it's obviously 9 cells, really 4 elements of data. You can see it at a glance. But look at the token sequence here. You have, of course, going line by line in regards to how that's fit into the machine. And without some sort of special delimiter, without some special information, the machine does not know that is a table. It just sees a string of text. And of course, that is the way language systems have been trained and run, is because you just give it a stream of text, it outputs a stream of text. That's a big problem because, as you can see here, that you can have multiple type of tables. So in this bottom bit, we have a merge table, which functions kind of a header as a way to describe, hey, what is this thing? Is it a Q4? Oh, yes, thank you. Appreciate that. Where was I? Oh, yes. So you have a header, Q4 2024 report. It's across it's across multiple things. So you know that every cell under it is actually an important and related to that topic. And then you have an urgent one that your spend, or rather the returns on these sales, is essentially 10%. And for someone who's in the retail business, that's very bad. And of course, they put a tag on there that says, hey, urgent. But you put that all into the machine, you have to then trust that everything is framed and organized correctly, that it knows that Q4 applies to the whole thing, and that urgent applies to that just one line item instead of to both information. Oh, well, one more thing. So this is assuming this is just the only data on the sheet. Let's assume that someone decides to cram as much information on, you have multiple tables on there, then you have to delineate that. And as you can see here, that formatting in LLM doesn't have color. It's colorblind, so it would not be able to see that very well. This is what the underlying structure looks like, is that especially Excel data is comprised of 3 things. The cell data itself, so all the numerical values, the formulas like summation, standard deviation, maybe some difference, or some like Levinson's if you're using like natural language type algorithms. That's going to be in formulas. And then styling, which is like all the big, bold, red things that say, hey, urgent, this is a big return amount, or we're losing money on this. All that is then rendered for a human to look at into a 2D field of vision, and not for a machine, or at least not for an LLM. So this is going to inherently a big problem if you try to just feed it into some sort of coding or reasoning agent that's not multimodal. And of course, if you multimodal, then you're going to have to spend a huge number of tokens vectorizing this whole space. And therefore, it's not a really nice really well-structured table in order to pull information from. Thus, you're going to start running into more problems. So numbers are from a while ago. I'm still gathering, and the reason why is because I haven't updated the slide. This is a lightning talk. So obviously GPT-4 is not the state of the art anymore. State of the art is getting better. It's still in the kind of 85 to 90% range, but still requires a lot of extra tooling, encoding optimization, perhaps some tool use, and then you're starting to get around human level performance. But without that, you're still operating well below that without doing some sort of special conditioning of the data, without some way of delimiting the data, so on and so forth. So I'm coming to the end of the talk because it was a lightning talk. Swix asked us to keep it really short. If this problem interests you, come up and talk to me. This obviously, there are 40 years. Think of it this way. There are 40 years of spreadsheets out there, and some of the most valuable spreadsheets are financial data and other types of like construction data, maintenance data. A lot of it is stored on spreadsheets, and a lot of it has very context and feature rich with formulas, a lot of stylizations, a lot of organizations that give information about that data. It's very useful. The problem is that it's not in a format machines can understand right now. So that's what I'm working on right now. If anyone's interested in reaching out to me, talking to me about it, hold on a second. Thank you. And that was a little bit larger than expected, but my QR code, if you guys wish to get in touch with me, that is my LinkedIn profile, and come and talk to me about if this is an interesting problem for you. Thanks.
Mrinal here, Oh, okay, cool. So you can take questions while Mrinal's setting up.
Yes, go for it.
Did you get my Zoom?
No, I didn't.
I was on Twitter.
Oh. You can, because not everyone uses formulas. So yes, the operative word is yes, but you're still, if someone has put in formulas that relate between information, or even worse, you have conditional formatting that is formula based, then you're missing a lot. So it's possible. Sorry? True. That's true. Yes. But essentially, a lot of those talk about that offline. There's strategies on how to do that, but the amount of constraint you have to way beyond that, to the point that you almost have to overlay some sort of structure or pretext the model in order to anticipate what's coming to it in order to better reason about it. Do you want to cover one more?
No, we're good.
All right. Thanks, everyone.
And if you didn't get a QR code, his socials are on the Luma, so you already have it.
All right. Hey, everyone. My name is Mrinal. I'm here to talk about how to make deep work agents. Okay. How to make deep work agents. So Charlie earlier in the evening talked about Claude Code and orchestrating teams of Claude codes, right? But how about making that happen in other domains, in other products, making that a feature of your own product? That's the problem I'm interested in. How do you make agents that can do complex things? And I work at Autonomy. Thank you, Swix, for organizing this and having me here. Really appreciate it. Thank you all for coming. Autonomy you can find us on autonomy.computer. And autonomy is two things. It's a framework to write and define agentic apps in Python, plus a runtime in the cloud to deploy teams of agents and agentic products, right? But it has some really nice, cool, unique features around doing deep work and creating large fleets of agents, think thousands of agents. In fact, later in my talk, I'll spin up 5,000 of them live in the call. Okay, so that QR code over there has a prompt on it. If you scan it, it's going to look kind of like this. And over here, I have a little video of my Claude code working through this prompt. But what this prompt says is refer autonomy documentation and build me a build me a multi-agent app. And about 11 minutes later, it's written all the code. And because it has a reference to the autonomy documentation, it also deploys it in our cloud runtime and then tests the APIs. And the end result is a deep research multi-agent app that spins up fleets of researching agents for news editors, right? So that's the experience. You can go try it later. But coming back to my topic, how do we make deep work agents? So everybody here is familiar already, but that's what an agent is, right? It's a state machine that's talking to a language model, and language models only are text in and text out. So the state machine is feeding in some information, the context, and the language model looks at that context and says, do these things next. And do these things next are expressed as tool calls, and the state machine that makes those tool calls takes the results, feeds them back into the context, and that's what an agent is, right? So this is a pretty standard agent. What's a deep work agent? An agent that can achieve long and complex tasks by making hundreds of autonomous turns. So if you've ever tried building an agent, getting it to do a few autonomous steps in a way that aligns with the goal, easy. Getting it to do hundreds of autonomous steps like Claude Code is able to do, fairly hard. And so in the rest of the talk, I want to talk about what those look like. So we're looking at use cases like conducting deep research, maintaining a long voice conversation. As an example, we have a customer on autonomy that's doing first round interviews using voice agents. And their initial prototype, the voice agent would conduct an interview, and let's say the candidate said, hey, I live in Boston. About 10 minutes in, the interviewing agent starts talking about Boston instead of talking about software engineering, right? So that's the kind of confusion agents will have when you try to give them long-running tasks. There are other situations like performing multi-step data analysis, operating on financial models, operating user interfaces. We saw some examples of all of this already, and doing legal analysis, etc. But the key thing to take away is it's not just the model. Yes, the models have to get better, and with examples today like Farah, Minimax, Claude Code, etc., the models are getting better, but there's also engineering we can do to make agents successful, and I want to talk about those engineering things. So we'll look at this example, okay? We'll build a legal researcher. This legal researcher is for attorneys. Attorneys will submit in a complex case. The case would be broken down into a set of research questions, and the agents will then research that question and return a comprehensive legal memo with citations. That's what we want to target. So the first thing that really helps when we're making deep work agents is giving them the ability to make plans and track progress against those plans on a file system. And you might have noticed that Claude Code does this, right? It writes down a plan.md and then tracks a bunch of stuff. If you're building a product, doing this and giving your product that ability is really, really helpful. So in autonomy, it looks like this. The agent.start part doesn't look complex. It looks like every other agent you might have already seen in Python code. But the interesting part here is over here in point number 2, we're saying, hey, save your research plan in a file called researchplan.md. And for each question, one at a time, first do a web search, collect a set of facts about legal statutes, and then collect the research in this file called question1.findings.md. So break down the case into a set of questions to research each question online, and then gather those results also in a file, and then generate a final memo.md that is going to be your final report. But the nice thing autonomy did here is it gave you these tools at the bottom. So it gave you the ability to run an MCP to a server and client, in this case, the Brave Search MCP to do online searches, but it also gave you a file system scoped down to this specific agent so that this agent can work on these files and generate these files and save them. It also gave you a knowledge tool. Knowledge is essentially a semantic search capability, right? So the agent is able to search legal statutes from a corpus of documents. And this is what the file system tools look like under the hood, right? So it's a collection of tools to list directories, read files, write files, but more importantly, search files. And these capabilities are really helpful in helping agents on their own manage their context, right? And autonomy not only gave you the tools for agents to make these calls, but also the underlying infrastructure for a per agent isolated file system. So that's the first thing that really helps. The other thing that's really helpful is take notes about key learnings on a file system and refer back to them. So we already saw an example of this here where we said, hey, as you're collecting findings, collect them into a findings.md and refer back to them when you're collating your final report. So what that does is it does this, right? So without nodes, an agent would have to remember all the information it saw over multiple turns. And this can easily run out of the context window of 100,000 tokens or so. And so then the agent starts to get less focus and it loses track of the goal. With nodes, so the agent saves everything it learns into files and it can search those files again when it later needs to refer stuff back. So it really, really helps. Okay, the next thing that's really helpful is curate and limit context at each step. So another thing that autonomy provides is the ability to define these context templates. And so you can define an agent, and then you can give the agent a template on how it should manage various sections of its context. And the agents by default in autonomy come with a default context template, but you can amend this template. So in this example, what I'm doing is I'm saying, hey, if you're searching the web, that's going to return a lot of pages that you should refer, take notes on those pages, and then you no longer need to keep those pages in context, right? So your tool call results of previous turns can be thrown away. And here in autonomy, you can define a section that says, maintain a filtered history that does not remember tool calls beyond a certain window of the last 2 tool calls, for example, right? So this makes it easy for you to then define an agent that does not keep tool call responses in its history. And the final thing that really helps is the ability to delegate work to sub-agents and do work in parallel. So in this example, I've modified our earlier example. And in this case, I'm now going to do things, instead of doing it one at a time, I'm going to do it with sub-agents. And here I'm saying, hey, there is a lead researcher agent that has been given a set of sub-agents, in this case, only one sub-agent called the research assistant. And to the lead researcher, I'm saying, hey, look at the case, break it down into a set of questions and give each question to a sub-agent and run those sub-agents in parallel and let them do the research on that specific question, right? And it's fairly easy to define. And now each specific research assistant has access to a file system and a knowledge base and the web searching capability. The sub-agent tools that autonomy provides look like this. They allow a parent agent to start sub-agents, to delegate to a specific sub-agent, delegate to a fleet of sub-agents, and even do it in a way that these sub-agents are distributed across a collection of machines. So once again, autonomy not only gave you the tools, it also gave you the underlying infrastructure that runs a massive distributed fleet of parallel agents. In this case, I'm asking the lead agent to do that, but in this other case, I could have also written a for loop and created those sub-agents myself and manually in programmatic logic managed a distributed fleet of agents. And just to give you an example of this, I'm going to run a set of, so in this example, which does not pause, so I'm going to let it run. We're spinning up 5,000 parallel agents that are in parallel researching specific topics. And what you'll notice is spinning up 5,000 of them did not take me 5,000 containers or 5,000 machines or 5,000 lambdas that can't stay alive for a long period of time. Instead, in autonomy, agents are modeled as actors, like Erlang actors or Scala actors, if you're familiar with that idea, which is very, very lightweight, so stateful concurrent entities, which means that we can very cheaply create massively parallel fleets of agentic workloads. So what this is a kind of like a distributed agentic map reduce like thing, if you're familiar with that algorithm. So the end result is, how do you make deep work agents? Is you need to give them the ability to make plans, track progress, and do that on a file system, because the file system is really easy storage for this type of thing. You need to give deep work agents the ability to take notes, and capture key learnings. And you need to create, curate, and limit context at each step, at each iteration in this turn long-lived, long-context agent. And then finally, you need to delegate work to sub-agents and run them in parallel. And autonomy makes all of that easy. So if you're interested, please give it a try. That's that QR code one more time. Thank you.
Very good. Okay, we do have to keep moving. We've got 2 more left, but obviously stick around to talk to her now if you're interested in more autonomy. But I'm very impressed by we're recording there. So there, slides and slideshow. You're good. Oh, wow. Why is your resolution so small?
Well, I went mirror.
Okay, you good?
I think so.
Yeah, good.
All right.
Last thing is to be on.
Turn that on.
You good? Good to go.
All right. Can everyone hear me? Great. All right. Well, I don't have a demo. I am just going to talk about something that is not announced. I'm CEO of a new startup company. We haven't launched our product yet, but when we finally launch, you'll recognize a lot of the things I'm talking about here tonight in what we eventually launch. And what I'm going to talk about specifically is domain-specific languages. And okay, great. There we go.
This is right.
Yeah.
It's comfortable.
Yeah, it's fine. Can you hear me?
Yeah.
All right. So everyone here is familiar with the promise of AI-driven code generation. And everyone here, as I'm sure, is directly experienced the increased productivity that comes with that. And the second point here, the improved quality and reliability, that's certainly a downstream impact of developer productivity. And a lot of people talk about this idea of democratization of application development. And this is one where I think the reality gets gets face to face with the practical.
I just got to fix the sharing, but keep going.
Yeah. Okay.
Do you know which desktop it is? Huh? He paused sharing?
Did I?
Yeah.
Resume. All right, we're good.
Okay. Sorry about that, guys.
Okay, we're good. We're back.
All right, there we go. Okay. So this idea of democratization of application development, there's really some fundamental issues that I think need to be addressed before we really achieve the potential of what people hope to from AI code generation. And I think the first one begins with a very obvious question: is, do people really know what they want? And there's the hypocritical story of Henry Ford asking his customers, what they want, and they replied, I just want a faster horse. And we really expect the users to really be able to describe exactly what they want in an application. And even if they knew exactly what they wanted, can you imagine them sitting down to a terminal and typing into Claude Code or sitting in front of an IDE and going through this demo that we started? I mean, could you imagine a non-technical person doing that? I think that's really a tall order and a stretch. And even if you could imagine that, how long is it going to be before Claude Code goes off down some sort of random dead-end path, with it exploding with thousands and thousands of lines of code, not really delivering anything useful to the end result? So I think this is a really big problem that I think is really underestimated. And then there's this idea of vibe YOLOing your way to success here. What does this code actually do? I think probably everybody here in this room has the experience of going through coding and suddenly it's like 30 new files and it's pulling in VM modules in there. It's like, well, I want my crypto keys, and you go, yo, whatever, bang, I'm done. And like, so there's something fundamentally wrong with this, and we can laugh about it, and we've all experienced it. But you bring that into an IT shop, and that brings the fear of God into them, and they're really hesitant about letting any of these things loose on their network to run wild. So these are problems that I think people really need to consider. And the AI code gens themselves, they are the unwitting accomplice, and we've all experienced this. We talked about it tonight, where Claude Code happily says, "Oh, you're so right." When you suddenly realize this thing is down some sort of dead end, and then you give it some little extra piece of information, and then realizes everything that it's done is wrong, and it could collapse this thing into a tiny little function call to solve the whole problem. So we've all experienced this, okay? And the solution to this problem, let me tell you, I believe that the root cause to this problem is really that we've got this problem space and the solution space, they're completely unconstrained. And you've got people asking for things that are impractical or insecure, and you've got the AI agent happily going off trying to solve these problems. And I think this is exactly what domain-specific languages can solve for us. And what I'd like to talk about here is specifically an internal DSL. And an internal DSL is really just a collection of Python or TypeScript classes. It looks and compiles just like any other Python or TypeScript. So there's nothing specific about being a language itself. It's really just a constrained version of the traditional language. And this DSL that I'm describing here is really just a constrained set of available classes for the generated code to use. And the constrained classes could include UI elements, page layouts, data sources, data connectors, and really even down to fine-grained capabilities to be like permission sets to access your SaaS endpoints, Workday or Salesforce or ServiceNow or whatever. But all those things collectively make up what I'm calling this DSL. In addition to that would be tool definitions, and importantly, definitions and examples that can be annotated into the context to help an AI code generation actually produce more constrained and reliable results. So that's what this idea of a DSL is to help solve this problem. And but then it introduces this other problem, which is, well, now you've got this constrained DSL, then how does the user know what's possible? So it's sort of this whole bootstrapping problem. But you can also imagine the use of this DSL to be within the context of a chat agent, that the chat agent can be used as like a product manager coach to help the user define their requirements and guide them to the result of a natural language description of the application that they want to build. So you can imagine that DSL being useful in the actual construction of the requirements themselves. And then if you think a little further, you can say, well, wait a minute, if this DSL is specific and it's got the classes for particular capabilities, if I sort of integrate identity into that, I actually can provide the sort of the security requirements to sort of prevent some rogue user building an application that does some kooky thing. I just sort of eliminate the class that provides the access to the financial resources. So if you integrate identity into this whole thing, it sort of begins a much more cohesive and complete solution to deliver real-world deployable apps into the enterprise. Now, the code generation part of this actually it can rely on instructor or the structured elements of the models to deliver. You provide it with a schema, and then it'll produce very compliant and compilable code out the back end. And then from there, you can just literally run this DSL, and it'll execute, and the artifacts that get delivered are the actual running code itself. So I talked about this interactive product manager agent here. It knows the DSL. And let me just quickly walk through an example of this. So you've got a user and he wants an app. He doesn't even know what he wants. He chats with the PM agent. The PM agent sort of has the DSL and can coach and guide them through that. So there's a series of interactions, but at the end, there's this document that actually becomes the source of truth. It is the artifact that can be version controlled and deterministically deliver the DSL, and then the DSL can be compiled into the production artifact. So again, that becomes the source of truth, that natural language description of the application. So this enables what I call, or a lot of people call this, security by construction, because what that definition, that DSL embodies, is the entirety of the scope that the application can, capabilities can perform. So if it's not in that DSL, the application isn't going to do it. So if somehow you're able to take that permission set out of the DSL, that application by construction will be prevented from exploiting or accessing that data. So here's a different scenario where you've got this identity-aware DSL, and the chatbot doesn't know who is accessing it, but it just knows the DSL that it has as its context. And this particular version of the DSL is missing some very sensitive classes. So as a result of that, when it gets down to this interaction, and the user asks for to put the workday salary into the application, the chat agent simply responds, well, I don't know how to do that. And then the user happily goes through, and they have an artifact that defines the application. But again, it is secure by construction because the exploit can't exist in that artifact. So I don't know how much time I have. I'm trying to go quickly here. Okay, so now you've got this requirements document. And then the code generation part of it actually uses this natural language requirements document as the user prompt. And then the system prompt can be the actual class definitions themselves. The PM agent that I just described, it can provide annotations for the specific use case that can drive the model to deliver correct implementations, example queries, and so forth. And then finally, the artifact here is going to come out. It's basically a Python file or a TypeScript file. You literally just run that, and Shazam, that thing executes and compiles and expands into all the artifacts that can be deployed as an application. And importantly here, this is 100% deterministic. It is compiled code. All of the AI inference and variabilities are pushed upstream into the application specification. And after that, it is all deterministic standard compiler capabilities that we're all familiar with, that also enterprise IT and security folks can trust and audit. So anyway, that's the wrap of my point here. So basically, being able to introduce a small amount of constraints to the problem here, we can actually trade off a little bit of scope for a great deal of certainty. And through that, we're able to get deterministic results. Then actually, there's some other things we talk about that can relieve the operational burden of actually running some of these applications. And again, getting back to my priority point here, I believe that this is something that's going to be necessary if we really want to enable that new cohort of application developers. So that is my talk. Thank you.
I think they're up next. Meanwhile, Chris can take a couple questions. I also want to shout out Chris for being the first responder on when I put out a call for talks. And if you're also wanting to chat, I'll be also available in the Sharing video. All set. Let's go. Cool. Can I borrow that? Sorry. Hi. Okay, so everyone can see my screen. It's perfect. And hi. So hi everyone. My name is Yusuf, and I'm the founder of a little startup called Muna. At Muna, we are building a platform that gives developers an OpenAI style experience to run open source AI models anywhere at all. Chris, I'd actually be very curious to hear what you think about my talk, because you might see some similar things. So in general, we spend a lot of time talking to the engineering teams, and right now they're struggling. So on one end, you have closed model providers like OpenAI, Anthropic. However many people in this room use OpenAI or Anthropic, pretty much all of us. And they're trying to lock you in, like very expensive, amazing models, but you know what you get. On the other end, you have open source models like Minimax, right? Amazing team. Incredibly competitive, but they're very painful to deploy, especially if you need to deploy them by yourself in your own infrastructure on custom hardware. And so a lot of teams end up having to duct tape infrastructure for every new model they need to run on every new device or deployment environment that they need to deploy on. And the question is, well, what if we could do better? So I have a very quick demo here for folks who are on iOS 26. It might not work because I literally put this in the car on the way here with cursor, but I'll very quickly switch over. This is basically a demo running a small, very small text to speech model called Kitten TTS. And so I'm just going to say dictate speech, and it should just say hello from engineer.
Hello from iEngineer.
Right. It's not the best text-to-speech model ever in the world, but it works. Right. Just very small just for this demo, so it won't take too much time. Now you might be thinking that, building that demo was like, it took me a bunch of like code, Like I said, I literally vibe coded it in the Uber on the way here and got like motion sickness. The code to actually run this is very simple, right? It's just openai.audio.speech.pa. But there's a problem in this code. There's like some problem with this code where if you actually install the OpenAI package, it wouldn't run. And can anyone spot the reason why this is wrong or incorrect?
The provider URL?
Yeah, well, close. The model name is invalid. So OpenAI does not provide any model called KittenML/KittenTTS. That is something that we brought by ourselves. So it's an open source model. OpenAI doesn't create this, but we can run it the same way. And so what's going on here? There's actually one more thing about this, where this is like harder for me to demo, but I have the same website running on my phone, which is impossible to show you all. I'm gonna put my phone on airplane mode, so if you open the link, you can do the same thing, and I'm gonna just do the same again, dictate speech. So again, bad audio quality, but I put off my phone is completely disconnected from the world, and it still worked. That means one thing: the model is actually running directly in my phone. So moving forward, the overall thing for us was we see the world of AI inference evolving in two ways. One is developers need access to all of the open source AI models out there. So I'll give you like a very quick example. Across all the closed providers, there's probably about maybe 50 to 100 different models you can use. Who can guess how many open source models are on Hugging Face today? Just ballpark. Scream a number at me. 2 million. So over 2 million. Whoever got that, amazing work. And then the other thing to keep in mind is, well, on one hand, we need access to these models. The other thing as well, there's so much more hardware now, like the folks at Microsoft, you're working with Qualcomm. The models are getting smaller, like R7B or like Minimax with like only 10 billion active parameters. And so we're getting into a world where we need to run inference on all the compute and all the devices that we have available at our fingertips, whether it's in the cloud, whether it's on your local GPU, on your desktop, whether it's literally on your phone, like I just demoed, or anything else. And so how do we fix this? Well, at Muna, we're building a compiler that takes Python code. So Chris, curious to hear what you think. We take Python code, we transpile that or compile that into C++ and Rust,
And then from there, we can then compile that C++ code, because it's just C++, to run on any device, anywhere at all. It could be in the cloud, it could be on desktop, it could be mobile, or on the web. So instead of like shilling or doing product stuff, I'll just walk through an actual example, show you how we manually do it, and then of course our product just automates this process. So please feel free to steal this IP and apply to YC and raise it a long way. So this is the actual function that actually generates speech from this kin model. It's very simple. It's only a handful of like lines of Python code, but TLDR takes in text, it takes in voice, and then does all this like running a model. The first step you need is to basically describe exactly what your Python function is doing. So we call this building an intermediate representation, or IR. And so like the first thing we actually tried doing, again, from like what Chris had mentioned earlier was, well, you can just give a language model your code, your Python function as is, you can give it a schema and say, hey, give me your best guess of how this Python function works based on the schema that I gave you. And what does that schema look like? Well, for us, we have very simple nodes. We have a function call, like, do stuff, pass in 2 arguments. We have a return statement in your function. We have an actual function, which just has a bunch of these nodes, and a few other types of nodes that you can use to build a function. The second step is, well, we need to now take this description that we've captured, which is, again, high level, close to Python, and lower it down to something that feels like C++ and or Rust. And so I'm just looking at a very like tiny part of the entire code just to really like give you guys a good example. So we have this convert to IPA International Phonetic Alphabet function that takes in text and a language and then gives you like an IPA string. It's used in a lot of like audio or text speech generation models. And the first operation in that function is just concatenating 2 strings, language plus text. So if I was going to rewrite this in C++, again, manually, no AI magic, well, I know that the text is a string because in my original function, I annotated it that the input text to generate speech is in fact a string. And also the language, if you see the very first argument there, the language is en-us, which is also a string, just US English. And so now I know the types of the two like text and language. And then to compute the prompt, which is like the next variable in my function, well, I don't know what the C++ type is, but what if I don't need to know? And this is where we use LLMs for code generation, because I can just simply ask an LLM, hey, write me some C++ operator or implementation that takes in 2 strings and concatenates them, and just the LLM will figure out everything it needs to do. So this is just like a toy example, very basic, very simple, but it gets the point across. And now I know that the result of concatenating 2 strings is in fact also a string. And so I can just repeat this process for every variable in my function until I've gone from high-level Python into actual C++ code that is self-contained, fully functional, and compiles. And that's it. And so once I compile it, I can compile it for a server, so for Linux, NVIDIA. I can compile it for like Apple Silicon, for my phone. And finally, I can basically, once I compile my function, the benefit of C++ is that you can run it from literally anywhere. And so here's how I basically make my fake OpenAI client. This is TypeScript for an example. Create this client class, create the audio class, create the speech class. And this is just pseudocode, it gets the point across, right? When I see a kin TTS in my original like Python that I showed you earlier, I resolve that to like the path of my compiled library. I simply execute that library because again, it's just a C library, nothing special, right? And then I massage the outputs to look just like what OpenAI would give me. And just like that, at the very bottom, I have something that looks and feels just like OpenAI, but it's not. And the best part about this is that not only can you run your inference now locally or on device, you can also run it server side, because all you need to do is take your inputs, send it off to a container in the cloud with probably a bunch of powerful GPUs, and just run it locally, but in that server. Bam. You now have inference that can run locally, remotely, in any place or on any device you ever want to, that feels just like a developer just using the OpenAI client in 2 or 3 lines of coding. And so yeah, that's it. So follow us on X. We are at Uzuna. You can follow me personally at Olakoba Yusuf on X. Join our Slack, so the QR code is to our Slack. And you can subscribe to my OnlyFans at Yusuf. No, it's not. Sorry to disappoint you. I don't have an OnlyFans yet. Yes, but I could be convinced. So yeah, that's our talk. Thank you so much for being capital on this. So Yusuf should take questions. I should also plug that he's currently the rating champion on the AIE online track, which is very competitive. So if you like to support the team of his work, go to the AI Engineer channel. That's just a consequence of like there's so many different like variables and instantiations we need to like make things unique.
No way.
But it's not an interesting detail. It's just a consequence.
Specifically, what I noticed was Musa was activating the scope operator to run like tensor.
Oh yeah, so Muda tensor is just like a wrapper class for us, like representing a tensor. So it gets a lot more interesting. I have to share more information, but I will next. Yeah, we are at the last one. This one's a little bit special. It's more about AI email. I just really care about AI email. I've been a superhuman user for 8 years. I just interviewed the superhuman CTO, and I cannot wait to quit superhuman. So when I saw an AI email talk, I was like, yeah. Okay, this is not sharing. So we need to do this. All right, last talk of the day. About half of you left. So this is pretty good survival rate. I think we need to switch to HDMI, so we'll just do this. HDMI. Sorry. Okay. All right. Last talk. That's a fucking long pin. Holy shit. Okay. All right.
Awesome. Is it mic on? Yes. Hi, everyone. I'll try to make this very interactive so that you're all getting the most out of it by having your attention here. Okay. So who here uses email? Everyone, right? That's how you're able to get the meeting to join here. So I'll tell you the story and dive into the product. So when I used to work at Google as a cloud AI engineer, I was one of the first people that really caught up to the AI wave and published a prompt engineering guide. And then suddenly everyone looks at the doc, and then everyone from different regions reached out to me and asking me about questions on, hey, how can I help this customer? Hey, I have a whole bunch of questions, completely unscalable because I can't do responding to the questions and doing my job, right? So what I did is I created an application on Google AppSheet and basically made it available for them. I called it Kidus AI, my first name AI, and I made it accessible for them on Google Workspace. So basically, instead of DMing me, they could DM it, right? And they would be communicating with this AI tool and would give me comments on how significantly this has impacted their business, their performance, right? So, I thought about that, and I thought, what would be the human AI collaboration platform of the future? What does it look like? We have ChatGPT today. We have many tools that have agents that do specific things. For example, for slides, for sheets, and so on. And we have platforms that connect slide agent, code agent, and sheet agent, and so on, and able to replicate very complex tasks. But fundamentally speaking, what does the Gen AI age work platform look like? That's the main question that we're tackling here at AlphaMail, MEIL.ai. So I'm gonna go from the pain points that people are having and show you how our application addresses it. So think about the 3 top issues that you're having with email. What is it? Is it summarization? Is it categorization? Do you get too many emails? Do you get, you don't have any control of your attention anymore? You don't control what to see, when to see, and how to see it, right? So all these are huge problems that we're facing with email. So that's what we're solving. So, for example, the main point here is to control your attention. We give you control of your focus, right? This is what the application looks like. When you log in, this is what you see. So these are my inboxes. So this is my inbox. Now, you can see that I don't even have to open any email to understand what it is about in detail. So we are envisioning a future where people don't read or write emails. We started with email. We're building the human AI interaction platform of the future, work platform of the future. But we're starting with email because it is the one thing that people have the biggest pain on in work, and it is also the lowest hanging fruit for generative AI. For example, this email, you have 3 profile views: the agentic, the invited trust. So I see the sender. This is the subject. This is the main concept. This is the summary, and these are the key topics. And these are the categories which I have defined. I can create any category here. These are all categories that I created, and it's very easy to create them. I just specify a name and a description. And based on my description, every email is going to be categorized based on my categories. For example, I can go to the emails that need attention. So I don't think I have any emails. Okay, maybe one here. Then this is an email that needs attention according to my descriptions. And I can create labels, so I can manually label the emails. And then priority, I can filter based on priority and category at the same time, right? And so I can create smart views. So, when I go to my email, sometimes I only want to see the emails that I want to respond to. So I go to the to respond view that I created, which is based on the to respond category, and respond to the emails. For example, this is an email. Let me respond to one of them, for example. Okay, this one, building guided build night events in San Francisco. Just respond, reply, generate, and it's going to generate a draft, a very accurate draft for me based on my conversation with the recipient, my tone, and my conversation about that subject with other recipients, right? So it generated this email. Okay, so I sent this to myself. And it's very fast at generating the emails. So you can see here, for example, I can reply to this email very fast. I just pressed it. If I can give it some context by voice input, or I can write and then generate the email based on the guidance that I give it. And then this is only one feature that we have. So here, I wanted to express my gratitude before. So I just review this and then I can send this. So you control your attention. Sometimes you want to go see your email to only look at the tasks that you need to do. You go to the task page. These are automatically extracted for you. For example, here I have review employment contracts and so on. So I have all these tasks that are automatically extracted. I can just pick one of them, and I have no idea what this one is. I go there, right? So I can mark them as done. I can delete them, and sometimes you don't want to spend time on identifying the emails you need to follow up for and drafting the follow-up. So it does it automatically for you. It automatically detects the email that you need to follow up to, and it drafts the email. So I know the UI needs improvement. We've been on this for 2 months. What I'm showing you is 2 months worth of work of a small team. So we've been building extremely fast, as you can see, because it has so many different intricate features. Yes. So, and then we have 2 promises. What I showed you so far is we reduce the time that you spend on email by 10x. The next one is we enhance your productivity by 10x with our agentic features. How we do that is through our agents. As I mentioned, this is a human collaboration platform that we're building. These are all the agents that I have, and I can direct message with humans and with agents. So, for example, here I have a co-founder that I was just chatting with before I came here. So, I have a 5 minutes. I have a talk in 5 minutes. What do you think I should talk about regarding AlphaMail.ai? Give me a response, and so on, right? So, I have a hiring scout. I have a strategic planner. I have a lead hunter, and so on. And then I can chat with one of my teammates here, for example, whom I was just chatting with, asking him about top 5 things he thinks I should mention in this presentation, right? So I can chat with humans and agents. I can have spaces with humans and agents. For example, in this product forge, I have a, let's see, I have 2 people, and then I have 3 agents: product innovator, customer success specialist, and metrics master. So this is the human collaboration platform that we are building. And another very interesting thing about how we're thinking about this is we price based on the number of hours saved. So based on how many hours we save you, that's how much we charge you, right? So all of that is detailed in the pricing page. You can see it also on the alphamail.ai, which I'm gonna look the QR code. And yeah, so this is what we're building. And just to give you a hint of like where we're going with this is we are doing fundamental research on how the human brain works, right? And how can we build software on top of it to simulate the human working process? For example, a human has expectations, metrics, timelines, goals, right? A human employee. We actually, all the things that I'm talking about, we have already built. It's only one feature that's called super agents that's not in here that I'm describing now. So this super agent is able to think and act by itself. What it does is its goal is to maximize its expectations and metrics based on its metrics. So it's going to message you in the morning saying, hey, as a co-founder, I saw that, like say, Superhuman, for example, is working on XYZ feature based on their LinkedIn post. What do you think about that approach, right? So it's a collaborator with you, and all the AI tools that that are built by other people. The vision is that you can work with them in one platform, such as this, where you can message via DM and add them to group spaces and work with humans and agents at the same time. And then yes, you can chat with your agent saying, for example, do I have any email from Google today? Right, and then it's going to give me a response. Yeah, so yeah, I found one unread email from Google. So yeah. Anyways, thanks so much, everyone. And so let me give you the QR code. I have 2 QR codes. This is for my LinkedIn. So if you want to scan it, please go ahead. I will have it here for 3 seconds.
It's also on the Luma.
Okay, awesome. And this is the website.
Okay, that was an impressive amount of software done in 2 months. You must have used a lot of hyper engineering as well. Okay, I intended there to be more mingle time, but also there's just so many good speakers. That's why we have so many talks. But we can meet outside. There's restaurants downstairs as well that we can go gather at. Feel free to mingle. We gotta clear our shit. So that's all for now. Thank you so much for coming. Thanks to our speakers. Thanks everyone, and sorry if I couldn't choose your talk.
Thank you so much. Impressive. Yeah, thank you. I would say, yeah. First, if I'm your friend, too many features. Cut half. It's like really fucking brutal. You gotta do it. Too much.
I see.
Are you an email platform or are you an everything platform?
Basically, we're trying to be an everything platform, but we're trying to start with email. So like
Then solve email first. It's too much.
So basically, go with email first and then proceed.
If you actually believe in email, do you?
Yeah.
Then go for it. You know, everything else that is not email, you're wasting your time.
Interesting. That makes sense.
Good luck.
Thanks so much, man. Appreciate it. Hey, how's it going? Thank you. Nice to meet you.